Hello and welcome to another video, this time taking you through a question which Issy has sent me, asking me to integrate this to find the exact value of it. Now, I've quickly just plugged it into GeoGebra because, you would just plug it into your calculator and you'd find the answer. So you know what you're heading towards, yeah? So you know how to check it in the end. Obviously, that's a tremendous way of checking your answer in the exam. It's foolproof, like just use a calculator. But we've got to show that the answer is whatever a calculator says it is. Now, according to my integrating graph software, it's 16. So let's have a look, see if we can get 16 from this. Now, I don't like their suggested substitution, but just in case they force you to do it this way, I'll show you how to do it with u squared equals 2x minus 1. And then afterwards, I'm going to try and do it with u equals 2x minus 1 to show you that you get exactly the same answer. Now, the thing with this, I just think it makes it more confusing. Okay, so we might take this over here and say u is 2x minus 1 to the half, yeah? And the most difficult bit in a substitution is actually subtly putting in your substitution and trading dx for du so that the thing ends up much simpler. That's the most difficult bit, but generally speaking, to start, you should always start by differentiating. By the way, you could rearrange this to u squared plus 1 over 2 equals x and find dx by du. That's a perfectly valid way of doing it as well. But anyway, if I'm differentiating this, the 2 I'm going to have to differentiate inside the brackets, giving me 2, but then the half's going to come down, and this is going to become 2x minus 1 to the minus a half. In other words, the 2 and the half cancel, and we end up with du is 1 over root 2x minus 1 dx. But I'd rather rewrite that actually as u du equals dx, because this thing on the bottom is just u. And so when I times it over there, I get u du equals dx. Now, why am I thinking of doing that? Well, because I want everything in terms of u, yeah? So I can now rewrite the integral as, well, it's going to be over u, yeah? Dx is swappable with u du, which means that these u's cancel, yeah? And then you just get 3 times whatever x is on the top, which is u squared plus 1 over 2. And so we do end up with something much easier to integrate. But like I say, normally I just use u equals 2x minus 1. Maybe I'll show you that way of doing it afterwards. Anyway, these are limits for x, remember. So we've got to change our limits into u. So I'm going to plug 5 into here. 2 times 5 minus 1 is 9 square rooted is 3. Because I want these limits in terms of u. 2 times 1 is 1, minus 1 is 1, square root is 1. Now our limits are in terms of u. And I get, okay, what I'm going to do is I'm going to take the 3 over 2 out, because I can think of the half coming out there, so it just becomes 3 over 2 times u squared plus 1. Then I've only got to integrate u squared plus 1 with respect to u. And now I can just say that's the same as u cubed over 3 plus u between 3 and 1. So now just carefully plug stuff in. We're going to get 27 divided by 3, well, that's 9 plus 3, that's by putting in the 3. And then we're going to get a third plus 1, well, that's 4 thirds. And now we can say, okay, that's the same as 12 minus 4 thirds. But if you like, that's 36 over 3 minus 4 over 3, which is 32 over 3. So we get 3 over 2 times 32 over 3. They cancel, and we get the answer of 16, which, like I say, is what your calculator will tell you is the answer, so you know you've done it right, which is good news. Okay, I just wanted to show you that you can use the or otherwise here. It's one of the very few questions where I'd be tempted to use or otherwise. Most of the time, the suggestion is the best way to proceed in maths questions. The or otherwise is a little bit like, okay, if you're a real maverick, a real loose cannon, try the or otherwise approach. Well, this isn't one of those occasions actually. It's actually easier if you do the or otherwise, I think. But let's see, yeah? So what would have changed if we'd used a slightly different substitution? Well, this bit at the start would have been easier, yeah? If I let u equal 2x minus 1, then du is 2 dx. In other words, I can almost straight swap this, and I can just say, well, half du is in fact dx. So I'm going to swap dx with a half du. Well, what's that going to give me? It's going to give me, okay, on the bottom, I've got the u to the power of a half. Dx is going to become a half du. But 3, I'm going to chuck straight outside. And then I've just got x on the top to deal with. Well, x is u plus 1 over 2. But I can take that half outside, making it u plus 1 over 4. The limits are going to change in the same way as last time. 2 times 5 is 10, minus 1 is 9. Sorry, they're not. It's actually going to be 9. They're going to be a square, so what they were before. 2 times 1 is 2, minus 1 is 1. But take out the other half, and so you get 3 over 4. And then you've got u plus 1 over u to the half. Maybe it isn't easier, I don't know. Maybe it looks much harder at this stage, I suppose. But you can still get the answer. I just wanted to show you it's not that much harder. Okay, now we're just going to divide both terms by u to the half. So we're going to have 3/4, but we're going to be integrating u to the half, because that's u to the 1. You know, if we do 1 minus half, we get a half. But then we've got u to the minus a half here, because 1 over u to the half is u to the minus a half du. Okay, so let's now do this bit. This bit might end up being easier, because we're going to get 9 square rooted. Well, yeah, let's do it carefully. 2/3 x to the u to the 3 over 2, increase power by 1 divided by the new power, you're going to get 2u to the half. Okay, this bit might be a bit more awkward at the end. Okay, 9 in here, square rooted 3, cubed is 27, divided by 3 is 9, times 2 is 18, plus 2 times 3, which is 6. And then we're plugging in 1, we're going to get 2/3 plus 2. So what have we got here? We've got 3/4 of, right, 24. 2/3 plus 2 is in fact like 8/3. And 24 is like 72 over 3. So 72 over 3 minus 8 over 3 is 64 over 3. And once again, we get 16. Yeah. So maybe the first way, maybe their suggestion was easier. Actually, I honestly thought this way was going to be easier. It's easier at the start, but you're just putting off initial pain for no gain later on, really. But there we go. Hopefully that makes sense now, Issy. I just wanted to show you there was a couple of ways of doing it. The key thing is simplify your integral as far as possible. Take constants out, and most of the time it's the algebra which gets the better of people in these kinds of questions, because the algebra is quite tricky, you know, like there's lots of fractions to deal with and stuff like that. Okay, thanks for listening, and best of luck with the exam. Keep up the hard work. Bye bye.